friends and fans of OSG, my name is Alyssa O'Brien, Product Engineer with OSG USA. Are you machining 3D printed parts or weld material? Stick around for this video covering tooling for additive manufactured products. When you think of 3D printing, what do you think of? If you're thinking plastic, you'd be a bit off for today's video. In this video, we're going to talk about cutting tools for 3D printed metal products. That's right, 3D printing metal is becoming more and more popular of an avenue for our manufacturing industry. And in this video, we're going to specifically tackle cutting tools for 3D printed metals that are very high on the hardness scale. Now, machining high hardened steel is challenging enough. But what about when the material is hard and you have a large cutting variance in the stock amount? This is not an uncommon situation for many manufacturers to have to work around. When it comes to CNC machining, this combo of high hardness and large variance in stock can easily be a recipe for chipping, tool breakage, bad tool life, slow production, and more. Keep watching and see what OSG has to offer to help alleviate your high hardness headaches. What is 3D printing? Another name for 3D printing is additive manufacturing. This is the process of building or adding material, usually layer by layer, to create a three-dimensional finished or near-finished product. And remember, we're talking about metals here. Today's technology can 3D print a wide variety of metals, such as Inconel, titanium, stainless steel, brass, and more. In the metalworking world, 3D printed parts can come from, of course, 3D printed machines, but additive manufactured products can also refer to those customers who are casting or welding as a component of their finished products as well. This method is directly opposite from the more common and traditional way of manufacturing metal products, which is accomplished by cutting metal from a block of material. This is known as subtractive manufacturing. Currently, OSG thrives in the world of subtractive manufacturing. Our cutting tools are used to remove material from parts. So why am I standing here talking about additive manufacturing? Well, the way additive manufacturing is today, many components can only be 3D printed to a rough state. And when I say rough, I mean rough. In comparison to a part that was roughed out completely from solid, a rough 3D printed part will usually have much higher surface roughness and a lot more fluctuation in how much material there is left to remove. This means that these parts will still require subtractive manufacturing to bring those products to a finished state. Because of the fluctuations in remaining stock, manufacturers take excruciating amounts of time to slowly remove the excess material. There's really no way around this. And the material is hard, and since the stock amounts are unpredictable, to save the cutting tool from breaking, you have to take super conservative depths of cut and usually decrease your cutting conditions. This, in turn, increases the overall cycle time, and that, in turn, increases production costs. So maybe now you can see how additive manufactured products can be a bit of a pain on the finishing end of things. Up until now, manufacturers have had to utilize the best end mill options for the job, which primarily defaults to end mills that are designed for high hardened metals. Sounds logical enough, right? While these tools will get the job done, they do typically have to be run slower and more conservatively to compensate for the roughness and the hardness of the 3D printed material. In answer to this drain on our customers' productivity, OSG is proud to say that we now offer both solid and indexable milling solutions for additive manufactured components. These tools will be able to provide you, our customers, with longer tool life, more consistent performance from tool change to tool change, better CPU, better finishes, and more peace of mind. I don't know about you, but these days, that last benefit is worth it in and of itself. In this comparison, we looked at a conventional 2-flute ball nose end mill designed for hardened steels to the new 3-flute ball nose tool for additive manufactured metals. Talk about tripping at the starting line. The conventional tool was able to mill roughly 28 feet before it experienced severe chipping that rendered it useless. Meanwhile, the 3-flute ball nose held strong through 984 feet of milling before the cutting edges towards the center of the tool began to wear out. Imagine yourself using that conventional tool. you would have had to do almost 36 tool changes before the OSG tool had to do just one. In this case, the number of tool changes alone could be a significant cycle time savings for you and your team. In this comparison, we're looking at the tool life of the replaceable head style end mill against two of the competitor tools for hardened steel. In this case, all tools are 16 millimeters in diameter, with the competition only having 4 flutes, while our tool has 6. Base milling this test part at almost 200 SFM and 57 inches per minute with a 12 thou depth of cut and 350 thou width of cut, air blow coolant, the OSG tool was able to last 13.9 meters, where the nearest competitor lasted only 2. What makes these tools so successful in these hardened 3D printed type materials? Of course, it comes down to the design. The general driving force for each of the designs of the new additive manufacturing, or AM series end mills, is an extra robust geometry, resistance to chipping, and sufficient flute pocket space. With the target materials having such varying amounts of stock and high hardness, these tools are designed to be able to withstand constant and unexpected fluctuations. The proprietary OSG DuraRay coating is OSG's best milling grade coating for hardened steel, giving the tools the necessary protection from heat and impact that is so prevalent in these types of applications. With these design improvements over conventional hard steel end mills, the OSG AM series end mills are the clear winners for hardened 3D printed material applications. OSG is proud to be the standalone tooling manufacturer to offer end mills for additive manufacturing. Here's a look at what we've got. The AM CRE is the OSG multi-flute radius end mill that comes in sizes ranging from 1/4 inch to 1/2 inch and 6 millimeters to 20 millimeters. The corner radius will vary by diameter, but generally speaking, we offer one large size corner radius and one small size corner radius for each diameter size. The AM EBT is the OSG 3-flute ball nose end mill and comes in sizes 3/32 to 1/2 inch and 2 millimeters to 20 millimeters. The length of cut on these tools will range from 1 to 1.5 times the diameter. The AM HFC is OSG's high-feed style end mill and comes with a through-the-tool air coolant hole feature and comes in size ranging from 4 millimeter to 12 millimeters. And last but not least, we have the PX HF AM, which is OSG's high-feed style replaceable head end mill, also featuring axial through-tool coolant ports in size ranging from 1/2 inch to 1 inch and 12 millimeter to 20 millimeters. Thank you all for watching today's video on additive manufacturing tooling. If you think the AM series tooling can be a good fit for your shop, or if you want some further information, please contact OSG at the number shown at the bottom of your screen. And if you haven't done so already, please subscribe to OSG's YouTube page for all the latest and greatest OSG tooling solution videos. You can also connect with us on Facebook, LinkedIn, and Instagram. Thanks again, guys, and we'll see you all next time.